Hello, everybody. Thank you for joining. I'm super excited to be here. My name is Leon Navid. This is not my first time on FOSDEM, but I'm in love in FOSDEM. So every time I'm on stage at FOSDEM, I'm super excited. First of all, thank you very much to Philippe, who has been running the Embedded Dev Room for 15 years in a row. There was a gap last year, and now thanks to this wonderful team, thanks to which we have the Embedded Dev Room again. They're a great team and they deserve it. So my name is Leon Navi. I'm working for a consultancy company called Consulco Group. The company is specialized in embedded development in various open source software. And today I'll be showing you some of the technologies that I use in my everyday work, like the Yocto project and Open Embedded, to build a makers project. And this project is Homebridge. This is the agenda for today. I have the ambitious goal to go through 30 slides in approximately 22-23 minutes and have a few minutes for questions. We'll see if it works out, or maybe not. First, we're going to talk about Homebridge. Homebridge is an open source software that enables various third-party devices to Apple HomeKit. How many of you are using Apple iPhone? I'm not using an iPhone, that's why I'm not raising my hand. All right, just a few of you. Don't worry, guys. The focus is actually on the open source side of things and building a custom GNU Linux distribution that incorporates Homebridge using the Yocto project and Open Embedded. We'll explore certain features of the distribution that I built, a lot of ideas for improvements, because this is a hobby project that I have been doing in the past few months, and there is room for a lot of improvements. And finally, there will be some conclusions. So, why I'm doing this? Obviously, the first answer to anyone on stage at FOSDEM is that we're doing these things because we can, and because it's cool and it's open source. However, the story in this case has another aspect. I have a very good friend from high school who is an electrical engineer, and as part of his job, he did a very complex setup with very expensive proprietary tool for a customer of his. And the customer asked him, hey, can I do this and that from my iPhone? And the answer was that actually this expensive proprietary tool at that moment, according to my friend, was not able to do it. So he called me for help to do something with free and open source software, which is obviously better in this case. And the answer was Homebridge. That's how we started. He bought a Raspberry Pi, of course. This is one of my favorite single board computers. And he asked me at his office at night to set it up. We spent a couple of hours to install Raspbian, to enable everything on Raspbian. Raspbian is, I'm sure you know, this is the default Linux distribution recommended by the Raspberry Pi Foundation. After that, we've installed Node.js, Homebridge, all plugins, all dependencies. So honestly, this is a little bit annoying and time-consuming process. It's pretty much going through a list of steps that you install things, and you are spending some time just waiting for the downloads and the installation to complete. And for me, it's a little bit annoying, but for non-Linux users, it could be even a little bit tricky. So after doing this, I proposed, hey, let's do a distribution that kind of works out of the box, or at least try to make it work out of the box. I wanted to have something similar for other complementary open source project for home automation that I wanted to run at home. I have numerous years of professional experience at Consulco Group working with the Yocto project and Open Embedded, so this was my choice to build distribution. So, in this case, I wanted to test the Yocto project and Open Embedded in the aspect of a maker. A few words about Homebridge. It's a lightweight server that emulates Apple iOS HomeKit API. It's written in Node.js, and it supports numerous plugins. With these plugins, you can attach various third-party devices, Internet of Things, or your do-it-yourself devices that are not officially supported by Apple. Nowadays, the Apple ecosystem is becoming more open. However, Homebridge has been a while for several years. It can be installed by macOS, Windows, and of course GNU Linux distributions. In our case, we're going to build a custom GNU Linux distribution. It's entirely open source. It's available at GitHub under Apache license. And this is the webpage of Homebridge where you can get started. Over these years, Homebridge has established a huge community. It was started by Nick Farina, who's based in the US. I have never personally met this developer, but he seems extremely skillful and very helpful. He's in Twitter, so we can find him, follow him, and say thanks for this great project that he has done. There are thousands of plugins developed by various contributors, and there are a lot of contributors to the core Homebridge Node.js implementation, and this is based on the work of a lot of people through the years. This is a short list of some of the Homebridge plugins which I think are useful to have. Of course, each plugin depends on the type of device that you have and the way you want to set it up. This is a very user-friendly plugin because this is a web interface which allows you to modify Homebridge from your web browser. And this is just a list of other plugins. I'm listing MQTT here because in our Linux distribution that we're going to build, I've included an MQTT broker. So let's build an embedded Linux distribution. How to do it? How many of you have built a Linux distribution from scratch? All right, that's fantastic. Pretty much the whole room. There's a lot of different ways how to approach this. One of the ways is the Yocto project and Open Embedded, which I'll be using for the rest of the slides here. Of course, other popular projects are BuildRoot, PDXDesk, which is having a talk later on today, OpenWRT, which is more for Wi-Fi routers, but can be used for other projects as well. And the most popular, in my opinion, maker approach is to grab a Debian derivative and to, change the root FS. This is a fast way to do it. However, it has some disadvantages. And Chris, who's over there, had an excellent talk that I would like to recommend you. It was at the Embedded Linux conference in Lyon. He was comparing what are the advantages and the disadvantages when you proceed with the Yocto project or use a Debian distribution. So, what to include in our distribution? When you start building an embedded Linux distribution, you need a board support package. In general, the board support package, as the name suggests, is provided by the vendor, the people that are manufacturing the boards. However, in reality, it's not always like this, but often there are community-supported board support packages that are pretty good. The board support package includes a bootloader, for example, U-boot, a Linux kernel, device tree drivers. After having the BSP ready, we need an init system. Systemd was my choice. I personally like it. I know that a lot of people don't like it, but yeah, that's my choice. We needed something for connectivity and interfacing the board. One of the problems that I've experienced setting up Raspbian with my friend for the very first time is that Raspbian is not intended for the things out of the box we wanted to do. So we had to go to Raspberry config and manually enable SSH, VNC, serial communication, and so on. And in my distribution, I wanted everything, all those interfaces to be enabled by default out of the box. We need Node.js and NPM because Homebridge is written in Node.js. I wanted to add a Mosquito broker. This is for my personal use, but I'm sure that a lot of you are already familiar with the machine-to-machine protocol MQTT. It's a really cool thing to have in anything related to home automation. We needed an X11 windowing system, and I decided to use X11, although I'm a huge fan of Way1. But for this project, I said, okay, X11 is okay. I put OpenBox as a compositor and a few basic applications. So even if there is a user without experience in Linux, if he starts the distribution, he has the basic things already installed there. One of the things that is interesting is the Surf web browser, very minimalistic web browser that is controlled only by keyboard shortcuts. And as soon as the distribution turns on, Serve presents the web UI provided by the plugin for Homebridge. And I wanted to add low-cost OLED display for some basic information, because the idea of this thing is that you're going to use, in most of the cases, this distribution without a proper HDMI monitor. So let's get started now with the Yocto project and Open Embedded. How many of you have been using the Yocto project and Open Embedded and are familiar with this? All right, that's good. So now comes the really hard part. Yocto is a great thing, but it's very hard to explain the terminology without messing the words. So forgive me if I make a mistake. So the Yocto project is an open source collaborative project of the Linux Foundation. It is designed to build custom GNU Linux distribution used in a variety of industries. The Yocto project has chosen the Open Embedded build system, which includes BitBake and Open Embedded Core. Pocky is the reference distribution of the Yocto project. It provides metadata, so you don't actually start from scratch, but you already have a list of recipes and layers on which you can, have a quick start, and after that you can continue customizing Pocky. The Yocto project has releases twice per year. These are the recent releases. The Yocto project and Open Embedded have a lot of contributors working on those projects. There are wiki pages with a lot of information, also mailing lists. So for the releases, the current stable release is Zeus, which was released in October, and in April we are expecting the next release. As of today, it's recommended to use the latest stable. That's why I've based what I do on version 3.0 Zeus. And if you follow the steps that you're going to see on the next slide, you'll get an image based on this Yocto project release. In long term, I plan to keep updating the versions of the project and to keep up to date with the latest releases of the Yocto project. So, in general, the Yocto project way of doing things is that you have various meta layers, and often when you are starting as a developer to make something, you need to put a list of and to download a list of layers. After that, to set up some configurations. To avoid doing this over and over again, I have used the Google Repo tool, which is a software tool for managing a collection of Git repositories. And with this command, you can get the manifest of the repo that I have created. After that, to run repo sync. And using a template, you can initialize the build environment. The build environment setup includes BB layers file, which is a description, a list of all meta layers used for building the project. And local.conf is another file where you set the machine, because the Yocto project and Open Embedded allow you with the same metadata and various board support packages to have the same image built for various hardware. In this case, for the moment, this distribution is supporting only Raspberry Pi. By default, we are building a 64-bit version of for Raspberry Pi 4. However, since we have the Meta Raspberry Pi layer included, you can manually switch the machine ID to Raspberry Pi 3 or previous model. After that, you have to type in BitBake. It will take a while, so please be patient. Spend some time drinking a cup of coffee or tea, and in a few hours you have the image. Alternatively, if you don't have a Linux machine, don't want to build the source from scratch, and if you want to act like a regular user, yes, there is a binary release in GitHub. You can just go there, download the image, flash it on a micro SD card, and use it. To flash it on a micro SD card, the recommended way for people that are feeling more comfortable with graphical user interfaces is Balena Etcher. Balena Etcher is free and open source software. You select the image, the drive, and just flash it. That's all. Alternatively, for those of you who are feeling more comfortable in a Linux terminal, you can do it with DD from the Linux terminal as well. So let's have a quick look at what's inside the image. This is Homebridge config UI X open in a Surf web browser. I have taken these screenshots. This is what you get as a user interface when you start. These are QR codes due to security reasons. I've just wiped out parts of the code, so hopefully I'm secure now. But this is what you're gonna get when you turn on the distribution for the very first time. It's a web browser that shows you this. If you have an HDMI monitor attached, this is what you're gonna see. Or if you connect via VNC, you will see again this thing. There are various connectivity and interfacing options enabled by default. SSH, for the moment there is no password, you just log in as root and it's up to you to change the password to something secure. There's also VNC running, so you can use VNC viewer to remotely connect to the device. And of course, serial console, so if you have a USB to UART debug cable, you can get some output. One of the things that is really cool about home automation projects is the ability to put them in a nice case and box. And this is a DIN rail case. There are several DIN rail cases available for Raspberry Pi. I bought both of those. I ended up using more disjointed cases. They're available as well as for Raspberry Pi 3 and 4. I designed a Raspberry Pi hardware attached on top. This is an add-on board that you plug on top of the Raspberry Pi. Several years ago, I had a talk explaining how to design these boards. It's a very straightforward process, actually. It's quite easy. I'm doing it with a free and open source software, KiCad, and this is open source hardware because it's available at GitHub. Super simple board with 3 buttons and a few slots for attaching I2C devices, one of which is the display. And here is the mini display. Those are low-cost, super cheap mini OLED displays that I've attached on top of the Raspberry Pi. Put it in the case. So if you mount this case on a DIN rail, you have some basic information like what is the IP address of this box and statuses of the system disk services that are more interesting, Homebridge and MQTT. This is the MQTT broker Mosquito. So how does it work? When you turn on the image for very first time, system disk services starts Homebridge and its plugins. OpenBox, which is compositor on top of X11 starts Surf. This is the web browser, and Surf automatically loads the web interface of the plugin provided for Homebridge. Also, there is a Python script which is showing information on the mini OLED display, which is attached over I2C. These are the layers that we are using in this distribution. As I told you, it's based on Pocky. Meta Raspberry Pi is the board support package layer. Those are standard layers that you can find in every Meta Open Embedded, like Meta Open Embedded, Meta Python, Meta GNOME, and Meta Networking. We're using recipes from all those layers. That's why they're included. And this is Meta Homebridge layer that I have created, and I put there some new recipes. This is the Surf web browser. How many of you are familiar with Surf? All right, it's pretty cool. Give it a try. It's just keyboard shortcuts. A web browser that opens in full screen and you only have keyboard shortcuts. Pretty cool and pretty convenient. So this is what you get when it starts. If you press Alt plus F4, it will just close and you have OpenBox. So OpenBox is highly configurable and very simple windowing manager for X11. There are just a few configuration files, and with those configuration files you can make a lot of customizations. So on the next slide you see how I have customized it and what you get if you turn off Surf. This is the screen that you get in the distribution that I've explained you how to build. As you can see, it's just a black dark screen with a few icons. I believe these are the minimal viable applications needed for even non-Linux experienced user to configure Homebridge and to feel comfortable with this distribution. I promised you to show you how to build Homebridge with the Yocto project and Open Embedded. This is a recipe. It's a standard recipe that's inheriting NPM. So in Yocto, there are a lot of classes that you can reuse. This is just a code snippet, not the whole recipe. So we are inheriting npm here. This is the name of the recipe, which is in green. This is the version of the recipe. And after that, Bitbake takes care of the rest to build it. This is Homebridge at npm.js. So if you want to install it manually, this is how to proceed for those of you who are familiar with Node.js. And I'm using the same URL to build it. This is the Homebridge system.dest service, which takes care of starting Homebridge when the application starts. I'll not go into too much details. The slides are available at SlideShare as well as on the FOSDEM page. I'll make sure to update them right after this presentation. So, what's next? Obviously, what I did for over a couple of weekends is not enough, and there's plenty of things to be done. One of the things that I would like to have is continuous integration and support future releases of the Yocto project to build a few images, binary images, so eventually people can start using what I have done. For the moment, there are just a few of us using it. Of course, it's a very new product. I want to support more hardware platforms, especially STM32MP1, which I think is a very interesting new system on a chip and would fit well for more industrial environment where there is dust and so on. Raspberry Pi is not the perfect hardware for this environment. Software updates over the air, either with Mender or OS3, both have advantages and disadvantages. Both are great, actually. And this is something that is on my to-do list to integrate. Both of those open source software solutions support Yocto project and Open Embedded. Integration of more Homebridge plugins out of the box. Once you start this image, you can install manually various Homebridge plugins. However, I would like to integrate more of them. So, hopefully you've enjoyed this talk, but even if you haven't enjoyed it, there are some benefits for the ecosystem because during my work, I was able to upstream some contributions to Meta Open Embedded, which are for Surf Recipe, Stallone Tray, and Update Mosquito and OpenBox. And at the end of this talk, I would like to share some conclusions. So first of all, it's something that I knew, and I'm sure you also knew before the start of this talk. Homebridge is a great open source platform if you are an Apple iOS user and want to integrate various devices with the Apple ecosystem, and it's an open source solution for various third-party devices. The Yocto project and Open Embedded are a great way to build custom embedded Linux distributions. It's de facto an industry standard used in automotive, in medical industries, in networking, in various Internet of Things. However, the last conclusion is about makers. The Yocto project and Open Embedded still have a steep learning curve. You have to learn a lot of things to get started. And when you build an image from scratch, it takes a significant amount of time, even if you have a powerful hardware. So still, for maker projects, it will take some time for you to get started with the Yocto project and Open Embedded, especially if you don't have previous knowledge. But the Yocto project has wonderful documentation, and I encourage you to give it a try. Thank you very much. And we have like 1 or 2 minutes for questions. Any questions? Yeah.
Why should someone choose Yocto over something like Buildroot?
Excellent question. So I also have some upstream contributions to Buildroot, and I like Buildroot. However, I personally use the Yocto project on a daily basis at my work at Kensuku Group, so I'm feeling more comfortable with Yocto. I think, just a personal opinion, it's a very sensitive topic. I think it's more customizable and more powerful in certain ways. However, Buildroot is a great choice as well. And there was another, can you please pass it?
Thank you for your talk. You said that you first did it on Raspbian, then did your distribution using Yocto. Do you have an estimation of how long it took you to do it on Raspbian versus how long it took to do it on Yocto?
All right, thank you. That's an excellent question. So the initial setup with Raspbian was a matter of like couple of hours, which included a quick crash course to my friend who was non-Linux user. For my distribution, it takes a significant amount of time to build this distribution from scratch. But once you have it, to get started, it's a matter of like 15 minutes to download the image, flash it, and get started. So from user's perspective, this is a very fast way to approach because it's a distribution made for this. Time is up, so thank you very much for joining. I hope you've enjoyed it.